This is MATHguide.com, and my name is Mark Karadimos. So in this video, we're going to take a look at how to determine the derivatives of polynomials. So over there in the top right corner, you're going to see that we have the formula for derivatives, and let's use it. Okay, so let's take a look at our first example. Let's say we start with the function f of x equals 2x plus 5. Okay, so here's our function. Well, the derivative says, the first derivative says we're supposed to take the limit as h approaches 0 of this function. Well, it says let's plug in x plus h into this function. Okay, well, in other words, I'm going to replace the x with x plus h. There you go. And then it says let's subtract f of x. So I'm going to subtract 2x plus 5. And I'm going to write it like this. Well, this is a common mistake that people do right off the start, because if I want to subtract the entire f of x, the entire function, I really have to imagine subtracting all of it. So those parentheses are mandatory. Okay, so if I'm going to find this first derivative, yes, I have to keep on writing this limit as h approaches 0. Okay, well, let's do this multiplication. So this is 2x plus 2h plus 5. Now let's subtract everything. So that's a minus 2x minus 5 all over h. Okay, so continuing, we could see a few things are going to happen. You could see that the 2x minus 2x, they cancel. You could see that we've got the 5 minus 5. They cancel. So let's take the limit as h approaches 0. And so the only thing left standing here, I believe, was the 2h. Okay, so we have 2h over h. All right, continuing on, we could see that if you divide this, you're going to get 2. So what's the limit as h approaches 0? Well, h is gone. There is no h value left with this expression, so the answer is just 2. Okay, so that means that if I were to take a look at this function, and if I said, what is the slope of the tangent line any point along this curve, and the slope is always going to be 2. And that kind of makes sense on a logical level, because if you were to take a look at this and graph this, it has a slope of 2 and a y-intercept of 5. It should always have a slope of 2. So our first derivative, which is the slope of the tangent line, is 2. All right, let's take a look at a second example. All right, on to our second example. So let's start with a different function, negative 3x squared. And what do I have here? 4x minus 1. Again, I'm going to use the formula for derivative. And of course, I do have a video there, MATHguide, we have a video that explains where that formula comes from. Anyhow, let's use it. So the first derivative is the limit as h approaches 0. Now, the first thing you have to do is figure out what is f of x plus h. That means in this function, this lengthy function, you're going to replace all these x's with x plus h. What a mess, huh? Okay, then we're going to subtract f of x. So we subtract the negative 3x squared plus 4x minus 1. Don't forget to put parentheses, so you subtract the whole thing. Okay, and remember this is all over h. What a mess. Okay, so let's take a look at what happens when we start to clean this thing up. Okay, now this is kind of involved here. So if I take x plus h times x plus h, you get x squared plus 2xh plus h squared. And I'm going to get, if I multiply this, I get 4x plus 4h minus 1, taking the opposite of all this. So it's going to be a plus 3x squared minus 4x plus 1 all over. Oop. H, I ain't going to do any better than that. Okay, so let's continue on. Okay, so right now this becomes an algebra problem. Multiplying everything here, you get negative 3x squared minus 6xh plus, oops, not plus, that's going to be a minus 3h squared. And again, all this is the same, plus 4x plus 4h minus 1 plus 3x squared minus 4x plus 1. Now, the other problem we saw was a little bit easier for me to kind of see what was happening. Now, I'm going to use a little bit of some marking here so that I don't lose anything. Okay, because things are going to start to cancel here. So I'm going to see if I could do this in, let's see, what color would be good. Black is the best it's going to be. So the negative 3x squared with the positive 3x squared, they are done 4x minus 4x, negative 1 plus 1. All gone. So the only thing that we have left are terms that have h's in them. So I have a negative 6xh minus 3h squared plus 4h. It's the only thing left in the numerator. All over h. Okay, now I'm going to scroll down. Definitely need some room here, so I'm going to scroll, and see if I can continue. Okay, well, let's see, f prime of x. Let's see, I'm going to do some division there. So let's see, if I take this divided by h, I get a negative 6x. Divide this by h, I get negative 3h. Divide this by h, I get 4. So now, of course, I want to let the h values go to 0. So that means this is going to go to 0. So picture, well, you know what? Don't picture anything. Let's actually write it in. So I'm allowing that limit of this function. In other words, all the h's go to 0. Now, let's put it in there. I've done it so far every step. Let's write that f prime of x. So this, of course, this is going to be 0, so you get negative 6x plus 4. And there you go. We do now have the first derivative. In other words, this is the slope of the tangent line. Slope of the tangent line at any particular point along the curve. Okay, so this has been MathGuide.com, and I know after seeing this video that you will feel compelled to like the video, I hope, and maybe even subscribe to the channel. Make sure you go to MathGuide.com, check out our other lessons, our interactive quizzes, and instructional videos. You will not be disappointed. '17th century mathematics.